So this session is on probability, and this part of it is on single outcomes and sample spaces, where there's only one thing happening. What's the chance of one thing happening, not two? So let's start with what probability is. It's measured in terms of something being likely or not, the likelihood. Probability measures the likelihood of an event happening. And it can be visualized or measured on a scale where 0, it's impossible that it might happen, and 1 is that it's certain. The one thing about a probability value is that it won't be bigger than 1 or less than 0. It's always measured in this range here. That's the 50-50%, but 0 to 1. In English, you might say impossible, very unlikely, unlikely, all of that stuff up to certain. So we can do this in as a good chance of rain tomorrow, or this or that or the other. Here are events then, and the following events might happen in normal discussion, and they say, what's the probability that the sun will shine sometime today here in Ireland? And it has stuck through the clouds there. That you will win the lottery twice next year. That there will be 367 days this year, and it will rain every day in June. Well, even though the winning the lottery twice seems outrageously impossible, the one thing that's impossible there is the 367 days. That's not going to happen. That's for certain. The other is so close to, near certain, you might think it makes no difference, but in some cases it can make that difference. So we look at some sample outcomes. When an operation is conducted, the results are called outcomes. So the possible outcomes when throwing a die are 1, 2, 3, 4, 5, or 6. If a bag is filled with 27 red, blue, and green counters, the possible outcomes if you just pick one out of the bag is that you'll either get a red, a blue, or a green one. Now, there might be more reds or more greens or more blues, but they're the possibilities of outcomes. The possible outcomes when selecting a suit card from a pack, the 4 suits are spades, club, hearts, and diamonds. Okay? Now, we start with the probability formula. It looks very long because it's written in English. But basically it says the probability that an event meets a particular condition is given by P(E), the probability of an event. And basically it's the number of outcomes meeting the condition over the total number of possible outcomes. So if somebody said we're going to roll a die, and what's the probability that it's even, what would the probability be? 3 out of 6, isn't that right? Or 1 out of 2, because you could say, well, there's 1, 2, 3, 4, 5, and 6 as possible answers. Of those that are even, we've got a 2, a 4, and a 6 as even numbers. There's 3 of them, so 3 out of a total of 6. The total number of numbers meeting the condition, the 2 does, the 4 does, the 6 does, and the total number of possible outcomes, 1, 2, 3, 4, 5, 6. So that's the equation seen in that sense, or 1 out of 2. You could have said, well, there's only 2 types of numbers. There's evens and odds, and they're equally mixed up here, etc. Now, the next one is, what's the probability of not E from set theory? And that says, what's the probability of not getting what you're looking for there? And that's the probability of an event not meeting the condition, where PE plus P not E is 1. It either happens or it doesn't. So you'll either get an even number or you won't. It either rains or it doesn't. It's either a Monday or it's not. So what's the probability of not even? You could go to the bother and say, well, 1 isn't even, 3 isn't even, 5 isn't even. And you could say, well, that's 3 out of 6 again, which is 1 over 2. Or you could say, well, the probability that it's even was a half. The probability of not even is just take the probability of even and take it from 1. So 1 minus a half is a half. So if somebody said, what's the probability, we do another question. What's the probability of getting a 4 on the roll of a die? What would that be? 1 over 6. What's the probability of not 4? 1 minus 1 over 6, or 5/6. So P E plus P not E is 1. So P not E, if I wanted this on the left-hand side, and I didn't want this bit, I would get rid of it by moving it over to the other side, or subtracting it from that side, so I get 1 minus P E. Is that okay? And that's how that works. All right? So that's that example there. So example 1, a card is drawn at random from a pack of 52 cards. One card. What's the probability that the card drawn is the Queen of Hearts? How many Queen of Hearts are there? 1. How many cards are there? So total number of cards like the Queen of Hearts, 1. Total number of cards, 52. P, Queen of Hearts, is 1 out of 52. So using the equation, and again what we're doing is we're building up this set of tools in your toolbox, and one of them for probability is that one there, and another one is that one there. So there are two of our equations that we're going to rely on for the probability questions. We'll continue. Write down all possible outcomes from an event or from a number of related events. Tossing a coin, rolling a die, and selecting a single card from a pack of cards. You might just take the first two there. Write down the possible outcomes from the first two. Sure, yeah. We use this hall a lot for various events and stuff. You can see there's various tracks in the ceiling there. So we can split the room into 3 different rooms. This is a room here, or wherever you can see the tracks. But sometimes you might come in here and the lecture will be taking place about here. Those seats that are behind you come out, and they come out into 200 seats, tiered seating. So it's like a standard concert or whatever. And then the screen would come down from there rather than from the end. So this would be one lecture room, like there. That's actually another room. You can see here the track there separates this room from that room. There's another 200 seats there. So depending on, there might be a show in or a concert or whatever, or various things. I think Ireland's Got Talent and a few other things have been shown from here a few times. Sometimes then there's a competition that transitioners do called the Formula 1, which is really cool, where they race the car. You know that one? It's really cool, and we run that here. It's really great. And they race the car from up along a track all the way along here. It's really, really, really good stuff. And then we sort of have shows when they're in, like The Young Scientist, where all the Formula 1, the gear. It's a lovely concert. You dress up in all the gear and the pit stops and the branding and the image and the car and the speed, and it's really, really a good event. It wasn't there when I was coming through. The Young Scientist was, but which I didn't do. But the Formula 1 is a good bit of crack. Sorry, just while that noise was happening there. Where were we? We were doing a question. Yeah, we were doing probability. Are you back, Max? Okay. So tossing a coin, generally we would just say you can get heads or tails in that way. So you'd say the outcomes will be one or the other. With the rolling a die, we might say 1, 2, 3, 4, 5, 6. And that would be the possible outcomes. Or from another part of your maths education, you might call those the sets. You know, there's the full set of elements that can come up. Now, selecting a single card from a pack of cards, that's quite a lot. So we might just say 1 spade, 2 of spades, 3 of spades, etc., up to king of spades and whatever. That might be the ace of spades if we want. And then we might say ace of clubs after that, 2 of clubs, ace of diamonds, and ace of hearts, all the way up to king of hearts. And hopefully we've got 13 times 4 or 52 cards. Well, they're not going to ask you to write out all those out. But write down all possible outcomes. So they're the outcomes. And then you can say, what's the chance of getting a 4 on a given roll of a die? You can say, there's only 1 4, and it's 1 out of 6. What's the chance of getting the 3 of spades? 1 out of 52. What's the chance of getting an ace? There are 1, 2, 3, 4 aces out of 52. What's the chance of getting an ace or a club? They're aces. They're clubs. It looks like there's 13 of them, and it looks like there's 4 of them. But this one here can either be counted as a club or it can be counted as an ace. It can't be counted twice because it's only there once. Is that okay? So if we went along the top 1, 2, 3, 4, we get 13, 14, 15, 16. So it looks like we've got 16 out of 52 for the probability of an ace or club. Is that okay? Visually, if everything was drawn out on a diagram like that, we could see it quite well. And sometimes maybe that is the best way to do it because we wouldn't be confused. Sometimes in our head, how does that work? And we're using formulae. But that's the way. So we're going to see where we go with that. Calculating probability. Roll a die and establish the probability of the following outcomes. Well, what are the outcomes first? What's the sample space for the die? What do we say that was? The outcomes that could possibly happen with the die? 1, 2, 3, 4, 5, and 6. So first question, what's the probability of a 1? Well, for that question, the probability of a 1, we'd say there's only 1 of them, isn't it? How many numbers are there in total? 6. Because what we're doing is, the only formula we know at this stage, pretty much, is that the probability of something happening is the number of ways it can over the total number of outcomes. Total number of outcomes, 6. Number of ways that meet a 1, 1. It's 1 over 6. That you get an even number on the roll of a die. The answer there would be even. 2, 4, 6. 3 ways meet the condition. Out of 6. The next one, odd number. Is that pretty much the same? How many odd numbers? 1, 3, and 5, is it? So we get 3. Many numbers in total? 6. Even number or 1? Even or 1? Even is 2. Well, that's a 1, we count that. That's a 2, we count that. It's even. Don't count that. Do count the 4. Don't count the 5. Do count the 6. So that's 1, 2, 3, 4. 4 out of 6, or 2/3. The last one is even. Or sorry, is it odd? Odd or 1? Do I count the first one? 1. Is that in? Yep. Is the 2 in? No. 3 in? Yes. 4 in? No. 5 in? Yes. Looks like 3 out of 6. Is that okay? Now, what we found here is that this is called A and this is called B. This is A and this is called B, with an or in the middle. And this is called A or B or whatever we want to call it. Now watch this for a moment. In this situation here, PA or B, A or B for even or 1, is that okay? Just using A or B, turned out to be PA plus PB. Because how did I get the 4, 6? I got the even by saying it's 3, 6, plus the 1, which was 3, 6, plus 1, 6, which is 4, 6. Is that okay? But in this situation, I got A or B, PA plus PB, and I didn't get 4, 6. Because why? Odd was 1, wasn't it? And that depends on whether things are completely ruled out, mutually exclusive in all those things. Is that okay? And we can deal with that. So in this case, we actually got 3 over 6 plus 1 over 6, but we had to take away, actually we got P, A, and B. That's the full formula. Can a number be both 1 and odd at the same time? 1 and odd at the same time? Yes. So therefore we take away that 6 and we get 3, 6. So we'll come back to this. All I want to do at this stage in this part of it is to explain that this makes sense. You've all the answers here correct because we just pull them down from the sample space. But when we look at applying formulae and equations, we have to say, are they overlapping in a Venn diagram or are they not, before we can add up the answers. So that's just a bit of caution. So calculating probabilities, we've done that, and that's the end of that subtopic.